Hello! Yes! And welcome to our Objective 5.5 sample problems. Objective 5.5 says I can write a polynomial in fact form given real or complex zeros, and that, my friends, is what we're going to do right now. So let's dive right in. Let's look at letter A here. X equals 2/3. 5 minus 4i. If 5 minus 4i is a 0, we know the complex conjugate 5 plus 4i is also a 0. So all we need to do is write these factors. So we'll say f of x. The factor that gives me 2/3 is 3x minus 2. Factor that gives me 4 is x minus 4. Factor that gives me 5 minus 4i would be x minus 5 plus 4i. And the factor that gives me 5 plus 4i would be x minus 5 minus 4i. And that is all we need to do. That's it. All right, let's look at letter B here. Oh my gosh, look at all these factors. So I got -2, 0 with a multiplicity of 4, -1/5, 7 minus the square root of 11. Well, remember, this is a irrational 0, so 7 plus the square root of 11 must also be a 0. Let's go ahead and write this one out here, f of x. All right, so I'm going to start with 0 multiplicity of 4 just to get that out of the way. -2 would be x plus 2. -1/5 would be, let's see, 5x plus 1. 7 minus square root of 11. So that would be x minus 7 plus the square root of 11. Remember, we're just switching the signs there. And then x minus 7 minus the square root of 11. There we go. Very nice. All right, let's take a glance over here at letter C. 3 plus 6i, 5 minus the square root of 7. All right, so looking at this, 3 plus 6i, the complex conjugate must also be a 0. 3 minus 6i, 5 minus the square root of 7, the conjugate of that, 5 plus the square root of 7. So this one's going to have 4 factors. All right, so let's break it down here. We got f of x equals x minus 3 minus 6i. And then x minus 3 plus 6i. And then 5 minus root 7 would be x minus 5 plus the square root of 7. And then x minus 5 minus the square root of 7. There we have it. So there's our 4 factors. So x equals 8 with a multiplicity of 2, 9/4, and 3 plus 7i. Well, if 3 plus 7i is 1, then 3 minus 7i must also be a 0. So let's break this down here. So we have f of x equals 8 with multiplicity of 2. So that'd be x minus 8 squared. Remember, the exponent shows us that multiplicity. 9/4. So that'd be 4x minus 9. 3 plus 7i, so x minus 3 minus 7i. And then 3 minus 7i, so x minus 3 plus 7i. Fantastic. All right, couple more sample problems. 0, 2/5 with a multiplicity of 2, 9 minus 4i, so 9 plus 4i. So f of x would equal x for the 0. 2/5 with a multiplicity of 2 would be 5x minus 2 squared. 9 minus 4i would be x minus 9 plus 4i. And 9 plus 4i would be x minus 9 minus 4i. Very good. All right, our final one here. Oh my gosh, look at all of these factors that we're going to have. 3/7, 6 minus 8i. Well, if 6 minus 8i is 1, 6 plus 8i is 1. 9 plus the square root of 2. If 9 plus the square root of 2 is 1, 9 minus the square root of 2 must be 1. So let's make our factors here. So we have f of x equals 3/7 would be, what, 7x minus 3. 6 minus 8i would be x minus 6 plus 8i. And then x minus 6 minus 8i for the complex conjugate. And 9 plus the square root of 2. So that would be x minus 9 minus the square root of 2. And then the conjugate, x minus 9 plus square root of 2. And there we have our factored form for that polynomial. All right, hopefully this video shed a little bit of more clarity. Again, not a lot of work involved with this. That's not the point. The point is being able to recognize the zeros and their factors and the relationship between complex zeros and irrational zeros and how they occur in pairs. Hopefully we're feeling confident. If so, go ahead and get started on those practice problems. This is Mr. Carter signing off. I'll see you next time.